On the plate today is Earth Science. Welcome to Norse Teaches Science, another Earth Science edition. We're still in the lithosphere. I've covered a couple of videos before this, and we're going to continue talking about some lithosphere topics. And with me, Mr. Norris, for today we're going to talk about the plate tectonics theory. So, by the end of this video, I can discuss the theory of plate tectonics and the support to it. See what I did up there? It's on the plate. I got jokes. Dad jokes. But they're jokes. Alright. It started with the Continental Drift theory. So the idea of things moving was something proposed by a guy named Alfred Wegener. He thought that all the continents once joined together. And he called this supercontinent, as it was called, Pangea. So the theory of continental drift said that Pangea happened 500 million years ago, and then it broke apart about 200 million years ago. The continent started to drift or move to their current conditions, and that all continents broke through the ocean. And it was a really good idea. There's a lot of support to it, like the shorelines fit together. And that's one of the first evidence of it, that the shorelines fit together. If you look at South America and you look at Africa, they look like they would fit together in a puzzle piece. Another thing is same fossil organisms were found on different land masses. So there was, in South America, you found this alligator type of fossil, and the same fossils were found over in Africa. And so they thought, well, they couldn't, it's too far away for them to swim because they did not have the right skeletal features to swim that distance. So they're like, they must have been closer together for them to live on both continents. They also found that mountain belts end on one coastline and reappear across the ocean. It means the mountains had to be made made at the point when the continents were together. And that they also noticed that ancient climates related. They could look at the fossils of the different plants and see that, oh, this place, which is cold now, had warm conditions. They actually have found fossils suggesting that Antarctica once was more in a tropical region based off some of the fossils or impressions they found. Now, there were problems with continental drift. Continental drift never explained why or how plates move, why they move or how they move. And they never explained how plates formed. And so continental drift was a good theory, but another theory came called the theory of plate tectonics that solved all these problems, that incorporated continental drift but explained the other parts too about the movement. So the theory of plate tectonics says the Earth's lithosphere has many plates. You can kind of see some of the plate boundaries here. They're in yellow. And the arrows show the movement in all the different plates. Plates interact in various ways when they move. Um, Things like earthquakes happen when some of these plates move. Plates move because of the mantle. There's convective currents in the mantle. And it also included the theory of continental drift because it's laid the framework for plate tectonics. So the evidence to plate tectonics, not just the stuff from continental drift, but here's some other evidence of plate tectonics. So the first one is called Paleomagnetism, and it's one of the most persuasive evidence out there. So when new crust is formed, coming up at the ocean surface, the the elements in there that are magnetic will line up with the poles, a positive towards the North Pole and a negative towards the South Pole. And so they noticed that there was a switch in some of the rocks as you go away from the center of the new crust forming to like continents. And so it showed the shift in magnetism in the poles over time. You can also look at earthquake patterns. Earthquakes are usually associated with plate boundaries. and so it's able to show where some of the plates meet. We also look at ocean drilling. We drill in the ocean for oil, and we notice that rocks near divergent boundaries are younger, and rocks near the continental margin are older. So that means that they must be making new crust at some points in the along the Earth. The next one is hot spots. And so hot spots happen in the middle of a plate, and magma rises to the surface. And it supports that the plates are moving, because you can look at Hawaii. Kiwaya, the oldest volcano that's not really active anymore, once was where the youngest island is. But as the plate moved, that volcano moved off this hotspot area, a fixed hotspot, so it no longer was getting magma to make it bigger. So Hawaii is the youngest island, and it's over the hotspot now. At some point, the plate will move and a new island will form. And there was other stuff too from the continental drift, like coastlines fitting, the same fossils on different land masses, and the climates. They all fit in with the evidence of plate tectonics. So, this is a little bit about plate tectonics. We're going to talk a little bit more about the plates and the plate movements and plate boundaries in the coming videos. But I really hope you learned something. And this is Mr. Norris, and I'm going to go get me a plate of food for lunch, and I'm out.